All right, Algebra 1, here is a video that I promised walking you through your video, or sorry, excuse me, your quiz. If you hear any sounds in the background, it's probably my child asking for crackers or dogs. So just giving you a heads up if those sounds start happening. So for number 1 and 2, I think that we covered these in class, just overall, just with some different examples and practice. But just in case, this would be, get that out of the way. Let me change some font colors here. This first one will be 6 more than. More than implies addition. So 6 more than the difference of. So when I read the difference of, that's telling me, okay, all of a sudden, I'm doing 6 plus the difference of something. That is implying that there is a group of something happening. So I'm going to say 6 more than whatever that is. That's implying a set of parentheses. Okay, so 6 more or 6 plus the difference, so subtraction, the difference of 9 and a number P. Okay, so that would be the answer to number 1. Number 2, the quotient of 10 times a number and 7. The quotient is division. So I'm going to be doing a division problem or a division algebraic expression. So the quotient of 10 times a number and 7. Okay, so the quotient of 10 times some number. And so the and is the other part of the quotient, or the denominator, if you will. The quotient of 10 times a number and 7. Okay, so very particularly here, I'm going to put my numerator in parentheses because number 2 says the quotient of blank. So the quotient of 10 times the number, that means 10x, all of that is in the numerator. So I want to write that in parentheses to make sure, say I need to put something similar in my calculator. If I do 10x in parentheses in my calculator, then my calculator is going to read that correctly. For number 3, I'm evaluating each expression for the given domain value. Something that you should have learned is that the domain value is the set of x values. So if I give you an x value, then you are looking at a specific domain value. For number 3, the domain value is when x equals 4. So instead of 2x, I'm going to say 2 parentheses 4. Keep the 3 plus, instead of x squared, I'm going to say parentheses 4, close parentheses, squared. Okay. And then from there, I'm going to follow my order of operations. My order of operations says first take care of any groupings. Specifically, we have learned parentheses, P for PEMDAS, or what I've showed you in class, G, GEMDAS, meaning all types of grouping. For this example, we've only got parentheses, so we're just going to address that. But when I look in the parentheses, it's just a single constant or a single term here and also here. So I'm not combining anything or performing any type of operation within the parentheses. There may be something I need to perform outside of the parentheses. Okay, so let's address order of operations again. PEMDAS, we took care of the groupings of parentheses. The next letter E is for exponents. Okay, and so what I notice in this problem is that I do have some exponents that I need to take care of. Instead of 4 squared, I want to actually evaluate or simplify 4 squared into 16. Okay. The next part of order of operations, the next thing you should do is multiplication and division. Well, we have 2 times 4. I'm going to simplify that into 8 plus 3 plus 16. Okay. Oh, I forgot my 3. And then from there, I'm just going to combine like terms. All 3 of these numbers are constants. meaning they are like terms. So I'm just going to add them together to get a total of 27. Number four. Number four is the same directions. Evaluate each expression for the given domain. Here I have two different variables, y equals 4 and z equals 2. So I'm going to say, instead of 8y, I'm going to say 8 parentheses 4, close parentheses, plus 12 minus 2, instead of z, 2 times 2. So I'm going to open up parentheses and I'm going to put 2 in the place of that variable. Same thing, complete your order of operations. 8 times 4 is 32, plus 12 minus 4. And again, we have combining like terms. All three of those terms are constants, meaning they are just single digit numbers with no hidden variables, no unknown values. So all I need to do is combine those like terms, and my total is 40. Number 5. Number 5 is, again, same directions. I'm evaluating this expression for the domain values of x equals 2 and y equals 5. So I've got 2 plus parentheses 12 minus 5. Instead of x, I'm going to open up a new set of parentheses and substitute 2 in its place. Continue with the rest of my problem. So the very next thing is closing that set of parentheses times 2. Instead of y, I'm going to say parentheses 5. Now, this is one of them that tripped a lot of people up on their quiz. This is one of them that I discussed with several people in class. If I didn't get to you, that's why I'm making this video. But this is a big one. So order of operations says handle the groupings first. Well, I've got several groupings here. I've got a set of parentheses here. I've got an overall set of parentheses here. But then inside of that parentheses, there's another set of parentheses, right? So I need to handle the most narrow focus groupings first. So I'm going to keep everything else the same up until that point. So I copied everything else except this most narrow inside this grouping piece, because order of operations tells me take care of what's in the grouping first. Well, I've got 12 minus 5 times 2. Well, now we're back to order of operations. Which comes first, multiplication or subtraction? Multiplication comes first. So I'm going to do, okay, you can do this two different ways. You can either say this is minus 5 times 2, which is 10. Or you can say negative 5 times 2, which is negative 10. The same thing, it will end up with the same thing. You'll either have minus 10 or you'll have plus negative 10. Those are the same thing. They will lead you to the same answer. Order of operations, okay, back again. I'm looking at order of operations for this statement, and that would be starting with the groupings, specifically the parentheses again. I've got 2 sets of parentheses here that I need to address. So 2 plus parentheses 12 plus negative 10, or 12 minus 10, will give me 2, times 2 times 5. That's the other grouping I need to take care of. 2 times 5 is 10. Now here's where another mistake was made. So the first big mistake on this problem was right here. A lot of people did 12 minus 5, then times 2. That's incorrect. So we have shown correctly how to do that in this step. The next thing, the next major error that I saw a lot of people making was right here. They would do 2 plus 2 first, then times 10. That is not correct if we're using order of operations, which we always do. Order of operations says which comes first, multiplication or addition. Multiplication comes first. So we need to do 2 times 10 first, which is 20. Then addition, which gives us 22. All right. Number 6 is a word problem, but it's just like those that we've seen in our homework and in our classwork. So shouldn't be scared of it. Should be just fine. The expression 7h plus 1.50d or 1.5d can be used to find the total earnings after h hours and d deliveries have been made. How much will Sally make after working 10 hours and making 3 deliveries? So again, the expression that was given to us was 7h plus 1.50d. However, I want to know how much Sally will make after working 10 hours. So instead of the variable for hours, h, I'm going to say parentheses 10 hours. I'm going to substitute that in. And instead of saying 1.50 or 1.5d for deliveries, Sally made 3 deliveries. So I'm going to say parentheses 3 instead of just leaving that as the plain old variable. And then from there, all you have to do is type it straight into your calculator or multiply by hand on paper to get your answer. Okay. 7a. 7a, determine the perimeter of rectangle ABCD as a simplified algebraic expression. Okay. So perimeter specifically of a rectangle is adding all 4 sides. The perimeter of any figure is the sum of all of its sides. So you could do this several different ways. I'll show you both of them. Okay. You could say this side is x plus 2. But that also means that this side is also x plus 2. This side is x plus 1. But if this side is x plus 1, so is this one. So notice I'm writing each of the sides in parentheses. That way I don't mess up any signage, which throws me off on my order of operations. Now you'll notice that you have 2 sets of x plus 2. You can rewrite that as 2 sets of x plus 2. You'll also notice you have 2 sets of x plus 1. You can rewrite that as 2 sets, parentheses, x plus 1. Some students started out immediately with this statement, and that is absolutely correct. But if you wrote this, then that is also correct. Either way you write it, you are starting off correctly. Now, the one thing that people messed up was combining their like terms and distributing if you use this second statement. So if you started out with this first one, all you're doing is combining like terms. So I have 1x, 2x, 3x, 4x. And then I'm going to add my constants. I have 2 plus 2 plus 1 plus 1, that would be 6. Okay. Now, if I distributed, or if I started out with this statement, then I'm going to have to distribute the 2. So I'll say 2x, 2 times 2 is positive 4, plus 2 times x is 2x, and 2 times 1 is positive 2. Then I would combine my like terms and I would still get 4x plus 6 using this second statement as well. So again, either perimeter equation that you wrote or expression, however you want to write it. Expression would technically be this. We're working our way towards equations / we're already there. Okay, so that should have been familiar with you if I would have put P equals. But anyways, as long as you ended with 4x plus 6, then 7a is correct. You're good to go. Now, 7b requires you to have that correct answer. It requires you to have the perimeter expression, which is 4x plus 6. If x equals 7, tell me what the actual perimeter is. Well, we're evaluating again. Instead of 4x, we're going to do 4 times 7. 4 times 7 is 28. Plus 6 will give us 34. This one we went over in class. So I'm not going to take a lot of time on it since we went over it with the entire class. Your final answer for this one is going to be negative 2x. Oh man. 2x cubed minus 2x to the fourth plus 4x to the fourth. And then you would combine your like terms. You would have negative 2x cubed plus 2x to the fourth. Now for the remainder problems of this quiz, we are solving very basic equations. And we'll walk through these. Some of them are simpler than others, obviously. Let me see if I can get my formatting back correctly. Okay, here we go. For number 9, this is one of the most basic ones that you'll have. I want to solve for x equals, and the only way I can do that is if I subtract 7 from the left-hand side. But think of it as a balancing scale or a balance beam. For me to keep it balanced and equal, if I take something away from the left-hand side, I also have to take it away from the right-hand side. So if I'm subtracting 7 over here, I need to subtract 7 on this side as well. X equals 5. For number 10, same concept. I want x equals something. The only way I can do that is if I add 4 to get rid of it on the left-hand side. But if I'm adding 4 on the left-hand side, I need to add 4 to the right-hand side. Negative 3 plus 4 is 1. Now, number 11 is a fraction. So we're going to have to handle this a couple different ways. If you're using a calculator, then I encourage you to continue using it, but be careful. Use parentheses when you are typing your fractions into your calculator. For example, for this problem, you've got negative x over 3 equals negative 4. To solve this equation, I want x equals. Right now, I have negative x divided by something. The only way to undo multiplication, to undo division is multiplication. So the only way that I can undo negative x over 3 is to multiply by its reciprocal. So if I was going to do this in my calculator, I would say parentheses negative the reciprocal of 1. Remember, there's a 1 sitting in front of that x. I want to leave the variable there, but I want everything else gone. So the reciprocal of 1/3 is what needs to happen here. The reciprocal of 1/3 would be 3 over 1. And don't forget your negative. The reciprocal of negative 1/3 would be negative 3 over 1. But if I multiply by that on the left-hand side, I also have to multiply by it on the right-hand side. Again, you're doing a balance beam situation here. And so now on the left-hand side, I have x equals. On the right-hand side, negative 4 times negative 3 over 1. If you use your calculator, you got an answer immediately. If not, you're multiplying the numerator straight across. Negative 4 times negative 3 is positive 12. Then you multiply the denominators. There's not 1 under 4, which means we understand it to be over 1. And 1 times 1 is just 1. So final answer is x equals positive 12 over 1, or just positive 12. Moving on to number 12. Same process here. We want to undo. Think about order of operations. We want to do groupings, exponents, multiplication, division, then addition and subtraction at the very end. When we are solving an equation, we are almost undoing order of operations. We're working backwards. So the first thing we want to take care of is the addition or subtraction by moving it to the other side. So to get rid of or undo -12 or -14, I need to add 14 to both sides. 7K equals, okay, 42 plus 14 is going to be 56. Then again, working backwards, I want to solve for the variable K. Right now I have 7 times K. The only way to undo multiplication right now is to divide by 7 on both sides. 7 divided by 7 over here just leaves K. 56 divided by 7 gives me 8. Moving on to our last two equations. This one is written a little differently. The variable is over here. The 11 is what needs to go. So this is a positive 11. The only way I can move it is if I subtract 11 on both sides. So -3x equals 44 minus 11 is 33. Now I want x. This needs to go away. The only way to undo -3 times x is to divide by -3 on both sides. And so x equals -11. Last one. Again, as always, just like we've been doing up here, if there is a constant, we want to get rid of it first. I've got a +2 here. I want to get rid of it. So I do the opposite, or I do the inverse, which would be subtract 2 on both sides. The fraction stays for right now. X over 5 equals 4 because I'm subtracting 2 on both sides. Now I've got this fraction. I want x equals. I have 1x over 5 equals. The only way to get rid of that is either divide by 1/5 in your calculator, or the proper way to get rid of that is to multiply by the coefficient reciprocal, meaning leave the variable, multiply by the reciprocal of its coefficient or the numbers that are left. So I want to multiply not by 1/5, but by its reciprocal, parentheses 5 divided by 1. But if I do it on that side, on the left-hand side, I need to also do that on the right-hand side. So I'm going to multiply by 5 over 1 on the right-hand side. Over here just leaves me x. On the right-hand side, 4 times 5 is 20. 1 times 1 is just 1, which means your answer is 20 over 1 or just 20.